Good morning. It is 7:30 this morning on October 2nd, and most of you know by now we had two massive M-class flares last night, followed by a C-class flare. And you're wondering, is it going to hit us? And we're going to get to that in a minute. I want to remind you the difference between a flare and a CME. A flare is a burst of light that lets out light and some gas. They're the hydrogen and the nitrogen, and they move at the speed of light. A CME has the heavier particles of all the different elements that are on the sun, which can include most of the periodic table. But that releases out and it moves a little bit differently than the solar flares do. So this produced both CME and a solar flare, okay? But unfortunately, it's going to be aimed mostly away from Earth. Not terribly bad thing, since these are fairly large and had the potential of causing some damage. So let's look at the M8. This is the last M-class flare. It was close to being X-class flare, which means it could have caused damage to satellites, power grids, cell phone towers, radio propagation, like our emergency services would have had disrupted radio service. All sorts of things could have happened. Could have caused interference with GPS and caused radiation to pilots and astronauts. Just a tremendous amount of things happen when we get these really big solar flares. So this is aimed up and away from us. So we doubt we will see much activity from this, but this does give us a really good view of how this loop reaches up. And this is about the midpoint range. So this isn't quite the full extension of the where it reaches up and breaks. Okay, so as this stretches out, and it'll get to the point it breaks away from the gravitational pull of the sun. And when it does, that loop, what's out here, is starting to break away from the sun. And this will break. And when it does, these ends will snap together and pull back together and create the loop. And it will push all this stuff off in a massive explosion like several atomic bombs. Okay? And that is called a magnetic reconnection. And these cause massive amounts of energy. And this doesn't just happen on the sun. This actually happens on the backside of Earth when we get a major aurora storm. Those auroras will stretch around our planet, and some of it will come into our polar regions when we get hit the first time with the auroras, but some of it stretches out behind our planet like taffy. And it does the same thing. It loops behind our planet, stretches out, and then it'll reach a point where part of it breaks away and snaps away and gets propelled out behind us, and then the ends will snap together, and when they snap together, they propel that energy back down those field lines and back into our polar regions, which gives us a secondary aurora show. And that energy, that magnetic reconnection, is enough to power the United States for 4 entire days. The entire United States for 4 entire days. And we're actually up there studying that with the MMS satellites right now. And you can look that up on the NASA webpage. It's called MMS Satellites. And it's really fascinating and interesting to study. But a project that you can do with your kids to start studying this idea of how plasma stretches and reconnects is to make taffy and do a taffy pull and watch it pull apart and how it kind of snaps back upon itself when you pull it apart. That is an interesting way to start a science experiment with your kids to talk about how plasma stretches and how it reconnects with itself, and how you can get that science experiment with your kids going. Really interesting way to pull it back in together. This is the first solar flare. You can see here, here's the flare, the light burst that's happened first. And here is the plasma being ejected out behind that flare. And some of this is going to fall back on the surface of the sun. Part of it is being ejected out away from the sun. So this is going to be again, it's going out and away from us. Now, jumping over here to look at our solar sunspot. This came from 3110. Okay, 3110 is over here on our outgoing limb. It is going away from us, but it is still to the point we might get maybe a little tip of it spiraling back. Maybe. We'll wait and see. But everything so far has been magnetically charged, electromagnetically charged, to be the same polarity as we are right now, and we're not getting anything connecting. So we'll have to see if there's any change. We have 3112 over here. This has gone to beta, gamma, delta. Now, I want to flip over in a minute. I'm going to flip over here and I'm going to explain that. But let's go down. We're waving goodbye to 3107. He's dying away and he's not going to make another rotation, I don't think. 3110 is really active. Going to be kind of glad to see this one go, I have a feeling, because this is now 20% chance of actually creating an X-class flare, and we don't want an X-class flare. Those are the kind of flares that cause real damage. 70% chance of a C, 35% chance of another M. It's already produced at least one M today. This is 3111. He's not doing much. He's kind of died away. Now, we're at 3112. This looks like a monster, and it is. We are at 80% chance of a C, 40% chance of an M, and a 20% chance of a X. And this is going to be Earth-facing in 3 or 4 days. Now, I want to go over what this means, okay? A delta is an umbra of opposite polarity in a single penumbra, okay? A delta groups are often very big. 90% of the sunspot have reversed polarity with a high level of activity, especially in big flares erupt. These have mostly complex and unusual or broken view of umbra. Delta groups are formed by the aggregated sunspots with the opposite polarity of various dipoles, which are linked and shared magnetic field lines rather than direct magnetic lines. All the spots are located in a penumbral region. The delta spots are rarely last longer than one rotation, and they decay quicker than other sunspots. However, new delta spots can form within the same region. Delta sunspots groups are usually not separate, but rather die together. Active delta groups emit strong high alpha emissions. Sometimes filaments can come out of this group. So this is what these sunspots can look like. And look how you can just almost see the boil to them. There's a lot of electricity there. So this is a beta gamma. So this is a sunspot group with beta gamma magnetic configuration, but contain one or more delta sunspots. So it's got all of it. So going back here, we've got beta, gamma, delta. So we've got beta, which is both polarities. We've got gamma, and we've got delta, which is the opposite, the bipolar within one penumbra. And I think this is your gamma or your delta area right down in here. You've got some deltas right here. This we have to watch. This is a monster. This can take out electrical grids. It can take down cell phone towers. It can interrupt emergency service radio propagation. It can hurt astronauts. It can take down satellites. This can cause major damage if it causes a major X-class flare. The Carrington event that happened in 1858 was an X-45. They saw auroras in the Caribbean. Farmers got up at midnight and went to work because they thought it was daylight. That's how bright it was. And the skies turned red in China. So we don't want something that big, because when the Carrington event happened, we didn't have electricity, we didn't have satellites, we didn't have everything we have now. But we had telegraph systems, and telegraph wires were catching on fire. They would shock the telegraph operators. They said some telegraphs were working all by themselves, and some telegraph offices actually burnt down because they just got overly charged. So these storms are not innocent. So when you pray for a storm right now, pray that we get some, but not the big one, because this is going to be capable of producing the big one. All right, and we've got 3113, which is right next to 10. It's a 5% chance of a C, but not much. And we still have 3114, and that is down in the corner there under that U-shaped filament, and it's not doing much. It's only a 10% chance right now, but I think this will develop. I'm seeing a lot more magnetism happening around it. I think this is going to develop into something around as it rotates around the next time. Jumping over here to our space weather page. Overnight, we didn't do anything. And we're all scratching our heads and saying why. And the only explanation I have is we must be electromagnetically charged to the same polarities. That's the only explanation we have for this one. We have to be bouncing off. And looking down here, this has been flat, just pretty much flatlined for the last 2 days. That makes sense. It hasn't really connected in any way, BZ or at all. We had some minor BZ connections, but nothing major. It's just not connecting, so it's kind of like we're pushing each other apart. We've had some density changes, but even the wind has been lackluster. And we know it's there. Looking at Lascaux 3, it just doesn't look as bright as it did. But if I was to, and you can see here where it's pushing out and away, we have something coming just bright out of here. You know, there's something coming out of here. We have solar wind coming at us, but I'm just not sure. It's got to be magnetically the same polarity. And I will close this with looking at this in the last. We have a coronal hole coming here. Like I said, this is 3114. this is changing shape every day. And I think this is, just kind of getting ready to start developing into something. Maybe not this time, but maybe as it rotates around the sun, this is going to develop into a big sunspot. This is still bubbling really good. This is kind of bubbling, and you watch up here, we'll get a few bright regions right there. They kind of bubble up and then they dissipate, but this is still really, really active. So we're going to still have a little bit of activity for the next couple days. We'll have to wait and see. We still have this big flare coming at us. We still have good filaments here, right here, that could erupt. Anybody's guess. I will leave it there. We had a great time last night at the beach. Sorry you guys didn't join us. We gave the kids glow sticks. They ran up and down the beach, had a blast, and we got some interesting shots that I will share in the next report. Meanwhile, everybody have a good time.